Hello, mathematicians. It's Mrs. Post. It is Friday, April 3rd. I know you guys are very, very happy it's Friday. It's the weekend. You shouldn't have any assignments coming in over the weekend, so that's good. Try to finish up everything you can so you can enjoy your weekend, relaxing, sleeping in, getting to do whatever you want in your house, in your pajamas. So, here we go, guys. Today is also Spirit Day. It's Virtual Spirit Week. I've seen a lot of students participating that are elementary, middle school, but I haven't seen a lot of high schoolers participating. So, got my Avenger shirt on, representing. Hope you guys do too. Your Avenger shirts with your pajama bottoms, no uniforms. So anyway, we're going to keep going with radicals today, and otherwise known as square roots. But remember, we're getting fancy, and we're not just doing square roots. We're doing nth roots, right? We're doing all different kinds of roots, not just the square root. So that's what's so fun about it. All right, so here are the answers from yesterday's classwork, and I just wanted to quickly give you a minute to jot down the answers. It's really just like a one-step process here. If you guys remember the rules from yesterday, and I'll briefly show you again later today, but remember you're just kind of checking to see what the root is, trying to see what the number is inside the radical symbol. So you guys remember that you don't see it, but there's a little imaginary 2 here, right? So that means you're rewriting all of your terms, not really terms, I always say that, your factors, with a power of 2. You know that 100 is the same as 10 squared, right? You know that y to the 4th squared is the same as y to the 8th. So you're just rewriting everything with a power of 2. You're not changing the value of it. You're just rewriting it so you can simplify it out and get rid of the radical symbol. You're like de-radicaling it. It's a weird thing to say. So over here, same thing. 121 is the same thing as 11 squared. X squared to the power 2 is the same as x to the 4th. And really just a strategy if you weren't sure how to get the 16 down to a power of 2, you could just divide it by 2. 16 divided by 2 is 8. It's a little cheat. So, and then you can try it. 8 times 2 is 16. So there you go. It's also to the power of 2. When you reduce it, you just get rid of all of the nth root. You get rid of all of the extra powers up there, and you just bring everything down and you get rid of the radical symbol. Make sure you're not writing it like this. I know I see students do that all the time. Well, the point of doing it was to get rid of that symbol. So make sure that you do that. See if I can erase this. There you go. Just remember, the whole point was to get rid of the radical symbol. So you're just rewriting every one of these factors, 225. So you're thinking, okay, what 2 numbers multiply to give me 225? Well, 15 does. Once again, we have 16. 16 divided by 2 is 8. You can try it like this. And just think about it. There's 2 8 to the 8. So you can 8 to the 8 times another 8 to the 8. Add up your powers. So it's going to be 8 to the 16th, right? But when you're multiplying, you're adding up your powers. Take a look at these and see if you guys have any questions. The only other one you might have had a question about is maybe number 5, where you have 32, a to the 15th, and b to the 10th power. And this whole entire thing is a 5th root. And so you're just rewriting every one of these factors to the power of 5. So 2 to the 5th power is 32. A to the 3rd, 5 times, would be a to the 15th power. And b squared, 5 times, would be b to the 10th. And when you reduce it, you get rid of the radical symbol and you just leave everything that was inside the parentheses. And the rest of everything can go away. So that's really how you do these. We're going to add to this a little bit today. We're going to work with positive and negatives of these, and I'm going to show you an online calculator you might like better than the one I showed you yesterday. So if you need to look over these somewhere, you guys can pause the video and write them down. I'm going to keep going. So something that I want to talk to you guys about, I know you guys love imaginary numbers, right? So we're going to just briefly touch on those today because we're going to work on simplifying some of these radicals that have negatives in them. We didn't do any negatives yesterday, so we're going to work on calculating those today. So we always say you can't have a negative number inside the radical. You can't have a negative number inside the square root. Well, you can, right? It just gives you an imaginary solution. You guys know that the square root of 16 is 4. You know that the square root of negative 16 is not only 4, but it's 4i, right? And technically we like to say plus or minus 4i, you know that. And once again, the square root of 81 is 9, but the square root of a negative 81 is 9i, right? Because you can't have a negative under the square root. You can, you just have to write it as an imaginary solution, right? And you can look at 45 like 9 times 5. I'll write that down for you. And the square root of negative 9 is 3. So you can look at that again. Remember, you have an I if you have a negative number inside the square root. Hopefully you notice these were all square roots, right? So this rule applies when you have square roots, right? The number right here is 2. You're looking for a pair of numbers, right, that are the same. So you can reduce it. These were all square roots. So this does work. But what if this was not 2? What if it wasn't a square root? What if it was a cube root, like a third root? Or what if it was like a fourth root or a fifth root or a sixth root? Well, the rules are a little bit different depending upon what the little number is. Remember, that little number is the index. So we're going to talk about that now. So remember over here, let's see if I can fix this. I don't think it'll let me change it. Pointer options, here we go. Okay, so remember over here, you have the number inside, that's the radicand. The symbol is the radical, right? We call it the radical symbol. The whole thing is called a radical. And the little tiny number up here is the index, right? Generally speaking, if we have a square root, we think that there's a 2 right here, but we don't usually see it, right? It's a square root, we don't have to put the 2 because you know it's a square root, like on your calculator. Well, this particular case, remember we called it an index, we talked about that yesterday. So I just want to briefly talk about what happens when you have, when this index is even or if it's odd, what do you do? Do you still get imaginary solutions? Okay, I'm going to give you guys some examples with these and see if it makes a little bit of sense. I hope it does. So bear with me here. This can be a little bit confusing, I just want to say that, but I just want you to know that I want you to write it down. And I want you to be thinking about just kind of listening to what I'm saying, try to understand it. You can pause the video, you can take notes on it, and the more examples you do with it, the more it'll make sense. It's not one of those things you're going to just get right away. It's one of those things you're going to have to think through, practice it a little bit, and then you'll have your aha moment. Okay, so remember, don't always expect to have the aha moment in the middle of my lesson. Sometimes it takes practice for you to really get it, right? Especially for you hands-on learners. So it takes a little bit of time, so it's okay. All right, so I have some examples for you guys I want to show you. And I think once we kind of look over the examples, it'll make a little bit more sense. So, okay, we're going to try these examples right here. We want to start going over this section over here on the left where we have an even index and we have a number greater than 0 inside the radicals. So you guys know the square root of 25 is definitely going to give you 5. We also know it could be negative 5 as well, so it could be plus or minus 5 here. With the fourth root of 81, and you guys need to be thinking 4 numbers, 4 of the same numbers that multiply to give you 81, and actually that is going to be 3. So this could be positive or negative 3 right here. So in these particular situations over here, you guys can be thinking, okay, well, in these cases right here, you can have a positive and a negative solution, one of each, right? One positive and one negative solution over here. Let's go ahead and try these blue ones over here on the right side. So this is when your index is odd. So you notice it's going to be a 3 as the little number and also a 5. Some odd indexes, but the number inside on these examples are going to be greater than 0. They're going to be positive here. So the cube root of 64 is actually going to give you 4. A positive 4 only. You can't have a negative solution here because if you think about it, if you had 4 times 4 times 4, it has to give you 64. If you had negative 4 times negative 4 times a negative 4, that would give you negative 64, and that is not what you're looking for. Your number inside is a positive 64, so it wouldn't work. So these rules apply for all of these situations. And over here, you're looking for the fifth root of 32. And in this particular case, it's going to be 2. 2 to the fifth power is 32. So this case is only also going to have one solution, a positive solution only, because 2 times 2 times 2 times 2 times 2 will give you 32. But if you have negative 2's, that will give you a negative 32. And right here you have a positive 32. It's not the same number, so it's not the same thing. Okay, so in these situations, you're only going to have a positive solution only, one positive solution only. Okay, now let's go ahead and look down here where we have some negative numbers inside. You guys are pretty used to it, but once again, you're going to see the difference between if your index is even, like if you have power 2, power of 4, versus power of 3, and versus power of 5. Let me go back, let me switch my pen to red, and let's go ahead and look at these examples right here. So you guys know that the square root of a negative 25 is going to give you an imaginary solution. So you know the square root of 25 is 5, but you also know it's going to give you an imaginary solution. And imaginaries always come in pairs. The same thing over here with the fourth root of 81. That's still going to give you 3. Because you're going to have a negative inside, and imaginaries always come in pairs. You can have a negative inside an even index. So in these particular cases right here, these examples, you will have a positive and a negative imaginary solution. When you have an even index and a negative radicand, okay? Let's look at the ones over here where we have odd indexes. So over here we have the cube root of negative 64. In this particular case, you can actually have a cube root of a negative number, because if you think about it, I'm going to draw this one out for you just really quickly. Negative 4 times, and we redid this, times a negative 4, that gives you negative 64, right? Right there, which is actually what number you had at the beginning. So that's okay. So the cube root of negative 64 is actually negative 4, and that is okay. You can have a negative root right here. That's totally fine. The same thing with this fifth root of negative 32. You can do that. You can have negative 2 5 times. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. That should be 5. 1, 2, 3, 4, 5. 5 negative 2's is going to give you negative 32, which is the number that you're working with. So with that in mind, that's fine. So in this particular case, the fifth root of negative 32 would actually be negative 2 only. So you'll only get one solution, and it'll be a negative solution here. Okay, and then last but not least, you guys, it shouldn't really matter here. You know the fifth root of 0 should give you 0, one solution. And also over here, the fourth root of 0 doesn't really matter what the root is. 0 times 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 0 is always 0, right? So in this case, it wouldn't really matter. Either way, you're just going to get one solution. It's just going to be 0. Okay, so this is one of those things where it's just the more you do it, the more you get used to it. But I just wanted you guys to have the rules. I don't want you to think that you could not have a negative number inside your radical. You can. It could give you an imaginary solution if it's an even index. If it's an odd index, you can have a negative number without having an imaginary solution, but you wouldn't have a positive solution over here. So just be on the lookout for those and practice with those a little bit. Okay, so this is something I wanted to show you guys really quick. I just want to uncross my leg. Hang on. Okay, so you guys, we have worked on Desmos so many times, and we usually use it as a graphing calculator. But I want you guys to start using it if you are having an issue with your calculator or something like that, you can't find it, whatever, it's broken, you guys can use Desmos.com, and you guys can use the scientific right here, and it will actually work, and I'll show you guys how to use it for a couple of the problems that we're going to do. So hang on just a minute. Keep the ink. And go ahead and see. I got it right here. Okay, so we're going to try a problem here. we're going to try to do, I'll show you how to use it. So you just go to decimals.com. If you look at the link, it's decimals.com and then it's /scientific. Just go to the main page and you guys can get to the scientific section. I'm going to try one with you guys really quickly because I know you may not have known some of those numbers we were just working with. So here are the buttons that we were working with. Like this is a regular square root. So if you guys want to take like the square root of 25, it gives you 5, right? Let's say we want to try the negative 20 square root, the square root of negative 25. Once again, it gives you that error. It gives you undefined, right? So you guys can just use the regular square root. But there's also the one right here with an N. And if you hit that, look at it, it allows you to change the index and it allows you to change the radicand. So let's say we want to find the fourth root of 71. Look at that. It just, you don't have to push enter. 2.9. You could do it with anything. Like what were the numbers we were doing? The fifth root of 32, and it was 2. So you can always use this calculator over here if you cannot find the button on your calculator. If you have a scientific calculator, there is a button like this. Remember, I told you that you got to be on the lookout for it, but it is there. I think the other one we did was 3 and 64, and that is 4. So there you go. So this is how you use, if you wanted to use the Decimal Scientific Calculator, you guys can do that as well. Okay, and so I just want to go back really quick and show you how to do this one right here. This is another one. Let's say we want to do the fifth root of negative 43. The fifth root of negative 43, we'll go ahead and calculate it for you. It's not going to give you an imaginary solution because you have a fifth root. And so it's okay. You can have 5 negative numbers because 5 negative numbers will give you a negative number. So that one's going to be okay. And you can try it on your calculator. Isn't that kind of cool? So you know that if this was, let's say 2, it's going to give you undefined. It's going to give you an error. You know, you need an imaginary solution. So you guys can play around here. You'll have some problems like these on your classwork, and you'll also have some problems like these on your next assessment. So just make sure that you're using your calculator. You kind of understand what that means. Okay. Let me go back to our PowerPoint. Where are we? We are right here. Okay. So I want to go over a couple examples with you guys. You should go pretty quickly. Okay, so here's the first one I want to go over with you guys. It is, we're going to do the square root of negative 16, x to the 4th, y to the 8th. Okay, so we have a negative here, and this is something that we've been doing today. So you guys should still be okay with this one. So we have a square root and we have negative 16. So you can just rewrite it like the steps say as whatever. Remember, this is a regular square root, so you need to write it as a power of 2. I know 16 is 4 squared. So you can just leave that negative here. 4 squared gives you 16. And then I know x squared to the power of 2 is x to the 4th. And then I was telling you guys earlier, the cheat is to take the exponent and then divide it by your index over here. So 8 divided by 2 is 4. It's a little cheat. And then 4 times 2 is 8. So that'll work out. And then once again, rewrite it without the symbols here. And you know that you can go ahead and take the square root of 16, which is 4. And you know because you can have negative 4 times negative 4 gives you 16. 4 times 4 gives you 16. You would make this 4i. And you have to have 2 types of solutions for imaginaries, right? They always come in pairs. And then just reduce it without the nth power. And there you go. You're done with that one. Okay. Let's try another one over here. All right, so let's do this one. Is going to be the one I wanted to give you was a negative on the outside this time. And then this will be x squared minus 6 to the power of 8. So go ahead and be thinking about this one here. We have a negative on the outside. That's okay. If you remember from yesterday, it just means the opposite. So, and you have x squared minus 6. And this is also a square root. So, 8 divided by 2 is 4. So that's okay. And if we take this whole entire thing and square it, 4 times 2 is 8, and that'll work out. And you have a power 2 here. Remember, this is also a power 2, so those cancel. You end up with negative x squared minus 6 to the power of 4. And that's how you rewrite that one. So really no difference, just leave the parentheses alone, bring that negative down, and then just reduce the exponent, okay? In this case, we were dividing it by the index, okay? I'm gonna give you guys a couple just like this, 2 more, and then we will be done for today. And go back, next, next. Okay, so these are the ones I want you guys to do now. I want you guys to try square root of negative 16 y to the 4th. So I'm going to go ahead and pause the video. You guys need to pause it too and try this one on your own. And take a minute and see what you guys get. All right, so hopefully you guys were able to reduce this one here. This is also a traditional square root. And hopefully you guys were able to write this one out as 4 squared, which gives you 16, and y squared to the power of 2. So remember, you can just reduce the powers right here. And this is going to be a plus or minus here, because you're going to have an I because of the negative on the inside, and you will also have y squared. And that's it for that one. Hopefully you guys got that one right. All right, let me give you one more to try. This one is really similar to the one we did on the other screen. So we're going to have a negative on the outside, and your expression is going to be y plus 7. This one's going to be to the power of 16. So rewrite this one as the power that's in your index, and then go ahead and simplify it without the radical symbol. All right, give this one a try. I'll pause the video, and you should too. When you reduce this one, remember the shortcut is to take that power of 16 and divide it by your index, which is 2. 16 divided by 2 is 8, and then 8 squared, not 8 squared, 8 to the power of 2, y plus 7 to the power of 8 to the power of 2. Hopefully you guys would see that would be 16, would be your exponent, which is exactly what you had here. So now remember, you can reduce it because remember your index was 2 and you had a 2 here, and you can just bring down that negative, y plus 7 to the power of 8. And you guys are done with that one. So hopefully that's what you guys got for this one. So what you guys are going to do, I have actually 9 problems for you to work on today. And you're going to go ahead and work on these, and I'll send them to you as a Word document and as a PDF file. You'll work on these 9 problems. I would love for you guys to show your work. Some of them, like you can see, you can pretty much just kind of do in your head as you kind of get used to it. The numbers aren't too big, especially if you use your calculator and you're just remembering to reduce them by the index. So work on the 9 problems that you guys are going to get today. And I'll show you in just a moment what they look like on the next slide. Work on those, turn in your work, and that's all you guys have for today, which is Friday. This is the last day of the 3rd quarter. Finally, you made it. Next week starts quarter 4, and we're going to continue with radicals next week. All right, guys, you have a fabulous day. Hang on just a moment, and I'll show you what the next slide looks like for your classwork. Okay, here you go. Here are your 9 problems. Like I said, I'll attach them to your assignment directions, and you guys can work on them on notebook paper, and just make sure you send it in today. And that is it. Have a great weekend, and please let me know if you need any help. I'll be in my office from 10 to 12 and 2 to 4 today. Have a fabulous day. See you guys later.